All right, welcome back. I know it's been so long. You may have to check to see if you're still enrolled in this class. I don't know. I'm exaggerating, but doesn't it seem like a long time? I don't mean that in a bad way. It just seems like a long time. Way back before we went on break, I did a presentation for this chapter. I didn't quite get as far as I wanted to, but that means that the schedule starting today is, let me just go back, make sure you got this. Today, questions on 3.7, which you've never had a chance to ask. And then we're going to have kind of like review, the beginning of the review today, which means Wednesday is what I call review 2. For Wednesday, I'd love to have you informally take the test in the book, have come with questions. And then, of course, you know what that means for Friday. Friday would be the test, chapter 3, logic. So that's where we're headed. Okay, so to begin that process, 3.7 questions. Let's see, 3.7 was the electronic circuits, wasn't it? Yeah. You either had to what? Take a logic statement and draw a circuit, or take a circuit and draw some logic. Now, let me just make a comment here. I kind of ran out of time last time, but is it possible, first of all, can you remind me, what does it mean when two statements are equivalent? The truth tables come out exactly the same, so they're like one can substitute for the other, the same results. Now, when you have two equivalent statements, it's certainly possible that one of them could be shorter than the other, right? And doesn't it make sense if you have two equivalent statements to use the shorter one? Yeah, it's a little more efficient, a little bit quicker. Guess what? When you're building logic boards, which are basically true, false, on, off switches, circuits, like I showed you how to draw, guess which circuits are the most efficient? If you have two that are equivalent, pick the one that's smaller. Why? It'll operate quicker. Anytime you can get a circuit that operates quicker, this is like gold in today's society. I mean, quicker electronics, that's what everybody wants. It gets done quicker, it's more efficient, it's, what? Probably doesn't burn quite as much heat, probably takes a little less battery power, and the battery lasts longer. All kinds of good things. So what I didn't show you last time, because I ran out of time, was if we took a logic thing, big old long logic statement, and if we found a nice short statement that was exactly equivalent to the longer one, well, first of all, hallelujah, praise the Lord, and then use the shorter one, less parts, easier to do a truth table, everybody's happy, right? And just so you know, there are people, that's all they do for their full-time jobs. We try to make logic circuits more efficient and shorter. It makes sense, because everybody, you know, I've never heard anybody brag, hey, I got a better computer than you, mine's slower. Yeah, right, who's going to brag about that? Duh, you want it quicker. And so, anyway, that's a big, now I'm not trying to say just because I taught you one lesson, you can probably be hired for one of those jobs. That was not my point. But the point is, you guys are actually doing the beginnings of the kind of activities that pretty highly paid people do. It's kind of interesting. Did you have a question? You bet. What was the overall goal on that one? Simple. Oh yeah. So here's an example of a network. Can we simplify it? Okay. So first of all, I wrote down the logic statement. And these are just helpers over here, right? These are what? Kind of the pieces. I need a P, I need a Q, I need a not P, and I need a not Q, so I just put those there. So let's start doing them piece by piece, inside to out. What's not P or Q? These two, and this rule is only false, so both are false. So that's going to be, except it's not or, it's and. So that rule is only true when both are true. There we go. So, not both true, false, not both true, false. Here they're both true, true, not both true, false. Okay? Not Q and P. So these two. Again, same rule, only true when both are true. So that's going to be a false. That's a true. That's a false. That's a false. Now we have to take these two guys and for them, only false when both are false. Both are false, false. Both are not false. And so forth. Okay? So now I've got down to this, and I just put a big blob here. That's kind of my result so far. And lastly, I need to AND that with not Q. Only true when both are true. So I'll take this and AND it with this. Well, they're not both true. Here they are, true. Here they're not both true, false. Here they're not both true, false. Final result, FTFF. Okay. So now we at least know kind of what the logic footprint is for this. Now the question is, can we come up with a statement that gives the same results, but is not so obnoxiously long? That's kind of the goal. Well, turns out it's P and not Q. Now, what you can do is just kind of play around here. If you take this one and this one and them, what do you get? False, true, false, false. Sure enough. Duh. P and not Q is the same as all of this garbage. And so, with this nice new circuit, look at how many less parts I need to draw this circuit than I need to draw the original one we had there. And so that's the idea. So now where it gets a little tough is how do you discover what other statement has the same footprint? I start playing around with kind of my tool columns, or maybe you recognize, I don't know. But anyway, I start playing around, and actually, here's another thing. Is there any other column right in the table that already has the same footprint as this? In this one, I look and I go, oh my goodness, this column has the same results as that one. Ta-da, there it is. Sometimes it'll actually be there, and all I got to do is find it. But if it's not there, then you can start trying different combinations of these things with ands and ors. And at the moment, I haven't taught you any circuits like this or like this. So your only choices right now for circuits are these two. So at least it's not that difficult to look through. You don't have that many to look through. Did you have a question? Is that what you were looking for? Okay. Yes. 15? Okay. I'm just going to take a quick look and see if I might. Okay, let's see what's going on 15. Same thing?
I just didn't get what the and again.
Yeah. Okay, I got to just get my head on what are they trying to get you to do here. Draw a pair of switching networks to indicate that the statements are... Okay, so draw two separate networks. Well, the first one, PNQ or P. I guess they're really, all I had to do is just draw these two. So, what's in parentheses here? PNQ. So the first thing I had to do is do what? A side-by-side for PQ. And that result is ORed, or stacked, with P. So there's that one. And then this one, there's not much to draw.
That's it. So when it says and like that, it's basically just the same.
Oh, I gotcha. No, they meant there's two parts to this. The part before the and, make a drawing for that, and after the and, draw it. You're right, that is confusing. When they used the word, they were saying that's two parts of the problem. Yeah, I can see where that would mess you up. Yeah, that's not the best worded question for that reason. Somebody else, or anyone else? Excuse me? I know some of you are probably wondering, did we do this chapter? I don't know. By the way, I'm not criticizing. The break was fantastic. I think we all need some time away. There's no doubt about that. Well, then the next thing I'd like to look at is, I already talked to you about schedule. So basically, let's start taking a peek at review. And what I usually do, I guess let's do this first. I run a little questionnaire. Here are the topics that we covered in Chapter 3. Now, this is strictly, so, the idea, next time, of course, we're going to have the whole period, and you will hopefully have taken the practice test, and anything that caused you any difficulty, I'm hoping you feel free to ask about, because that would be great for everybody to talk about. Study. So, this is simply for today. What should we start with? What were your highest priorities? So vote for as many of these as you like. Okay? So, how many of you would like me to start with statements? I'm going to change colors here so I'm ready to go. Anybody? Statements? Truth tables? The conditional and the biconditional. That's this guy and this guy. Okay, thank you. Euler diagrams. Remember, those are circles inside of circles and X's, and you can vote. You don't have to, that's just fine. Okay, then, truth tables and telling whether an argument was valid. This is where we circled certain rows, things like that. Switching networks was the lesson we just finished. Wow. Okay, we were a little bit slim on the voting there. But the winner is the conditional and the biconditional, so that's where we'll begin. I know not everybody won, but at least. And then after that, we have a whopping four-way tie. So we could go to just about anything except statements after that. Okay, well, let me do a quick review. The conditional is another name for if-then. And the main thing I taught you in that lesson is what? I guess the rule is what? Only false when first is true and the second is false. I'm going to guess, because of our layout, we probably all need to review those rules. But anyway, that was that one. The biconditional was this double-headed arrow, and it means what? Well, first of all, it means if P then Q, and if Q then P. It's kind of like the arrowheads going both ways. It's also called if and only if. Thank you. That's the phrase that it often appears in English. Yes. And what's the rule for this? Yeah, true when they're identical. So TT comes out true and FF comes out true. And if they're different, TF or FT, then it's false. Let's see. Why don't I go, as long as you guys, that was the popular result, I'm going to see if let's go to that section and I'll pull out a couple problems. Looks like we're on page 133. Yeah, well, first of all, on page 133, could everybody look at that? I'll try doing a couple oral questions first. How about number 7? I know you had this for an assignment. Find the truth value. Here it is. If 2 plus 2 equals 22, then 4 equals 26. Yeah, I know, it's pretty much a pile of trash, but you got to think of it, it's not very useful, but you got to think of it from a truth value point of view. The first part of this if-then statement is false. The second part is obviously false. Now, all they're really asking you is in a truth table of this type, what happens when P is false and Q is false? Answer? It's true. Remember, the only time an if-then statement is false is when the first is true and the second is false. So if the first is false, remember this weird situation that's actually guarantees it's going to be true? You know, it's kind of like if pigs fly, then, I don't know, then gravity will stop working. And that's a true statement because, last I checked, pigs don't fly. Yeah, I know you can always make exceptions. Some pig in some jet flying someplace who is some rich lady's pet. Okay, that could be true, but I meant the flapping the pig fat flying. It's not going to work. Okay. How about I'm trying to find some more problems in this section. Excuse me a second. Oh yeah, here's a good one. Look at number 50, everyone. 50, page 134. It says, translate this into an if-then statement. Okay, now this is a little bit of a stinker. Alice fails the test or she gets the job. Let's just say let's say, let me put a couple things up here. Let's say that P is pass test, and let's say G is get job. Okay, so let's start with that. Now, if P stands for passing her test, and G stands for getting the job, how could we start by writing this statement logically? Alice fails the test, so that would be not, she did not pass it, or she gets the job. All right, now that's fine, except for one thing. Did you? So we have a good beginning, but did you notice what the directions said? Write this statement in if-then form. Wow. I don't have an if-then form up there. This is a stinker. This comes from a hint. Does anyone remember? Couldn't. Yes.
Not something or not A or B is the same as if A then B.
So this is the equivalent of? Yeah. So, you know, here, let me put this together. So what is this a reminder of? These two things are equivalent. And so that was a hint in one of the assignments, and it has kept coming up over and over. So guess what? That's a hint. You need to know, you need to have that handy. That's a tool. You know, if I ask you, here's another way this may come up. What if I gave you the statement, if P then G, and I asked you to make a network diagram? And instead of sitting there going, oh, doggone Velo, he told me that we'd only have to draw diagrams for these. And then he gives me one of these. Hopefully, instead of complaining like that, you probably, oh, wait a minute. There was a hint. if I have one of these, I can translate it into one of these. That's the same as not P or G. Oh, I know how to do the diagram for this. That's a stack, and then you're off and running. So there's two different ways already that needs to be remembered. So here's an item for your study list. Does anybody see another let me have you guys pick something now from the conditional, biconditional lesson, so that I haven't just picked things that I want to do. So, yes.
Can you go over number 60? Just
Sure. Let's see what we got. Here's an excerpt from an automobile insurance policy. If the loss is $50 or less, we will not make any payment. If the loss is $50 or less, we will not make any payment. So, in other words, it sounds like what? Like kind of like $50 deductible, maybe. But anyway, so if somebody scratches your car and you go and get the bill and it costs $49, you are going to have to pay the whole thing yourself. Okay. Now, a policyholder suffers a $75 loss. What are the insurance company's options? Well, it's not $50 or less. But one thing is, I don't think that statement up above is clear. What do you think what could the company do? I mean, we haven't heard all the rules, but what are their options? They could, okay, when you say not pay it, you mean just flat out refuse to pay it? Yeah, they can always do that. They could.
It doesn't say anywhere that if it's above 50, that they will pay it.
Very good point. Logically, it doesn't say a doggone thing about above 50. They might say, if it's below 50, I'm not paying it. And if it's above 50, go take a hike. I mean, we don't know. You're right. Good point. What's another? Yeah, and I hope that's not what my company says. Well, what's another thing they could do and still be true to this?
Pay 1 cent, and it would still be true.
Pay 1 cent? That's true, they could, yes.
Well, it doesn't matter how little or how much they pay, they're just stating that since the loss is over $50, they're going to make some kind of payment.
Good point. What are some other things they could do? It's kind of a weird question because we don't know if we were going to buy a policy, we're not going to just read the part where it says if it's less than 50, I'm not paying. We're going to want to read the rest. All right, what happens when it goes over this and over this? And what if I get sued by another driver for $30,000 or more? These are all things you want to know, but we don't know. What else could they do?
Just get a 50, and then do the rest of
Or, well, that would be nice. Or how about if they just paid the amount over 50? Wouldn't that, if it's really a $50 deductible, maybe they could cover everything over 50. Wouldn't that would be more consistent? Like, I'm sorry, we're not paying for anything under $50. So if somebody steals your CD and it's worth $13, too bad. We're not giving you anything. But if you had $75 worth of stuff stolen, hey, we'll pay for the amount over 50. So here's $25. That would kind of be like a deductible. I don't know how many of you have gotten into the wonderful world of insurance. But, you always will get some deductible, and I got news for you. It's rarely 50. It's usually 500 or higher. So if you mess up the front fender, and the front fender costs $1,250, you're going to have to pay the first 500 or whatever your deductible is. Anyway, you probably haven't had to worry about that yet. So it won't be long. That's going to be facing you. It's wonderful. Yeah. And, there's some cool things, too. Like, I don't know if you've noticed, but some companies are now giving refunds if you have a year with no accidents. or lowering, there are some companies that kind of reward you for safe driving too. But let's face it, in the end, they're going to get their bucks. You have to have insurance because, I hate to say it, we live in a very, lawsuit-oriented society. And, you might gently bump into a car in front of you at a stop sign, and the guy comes out and goes, I'm crippled for life, and they sue you for messing up their whole life. And you never know. Some people win those things. Well, without insurance, your financial life would be gone. So anyway, I want to urge you not to try to live without insurance. I think that would be way too risky. Does anybody have another question? Okay, maybe we should just split off. Should we look at a few Euler diagrams?
Yep. The last section.
Yes.
Stefan mentioned a statement which is in the logical negation of another.
Yes. Okay. Now remember, a negation, it's kind of like the question I keep asking people is, what would it take to make me a liar? So, if I said, here's that one I keep using over and over. If I said to my wife, if I get out of work by 5 o'clock, then I will go buy bread. What's the one thing it would take for that to be a lie? If I got out of work by 5 o'clock and I did not go buy the bread, I am in deep trouble, okay? That's called a lie. So what's the negation of if I get out of work by 5 o'clock, then I will go buy bread? The negation is I get out of work by 5 o'clock and alas, I do not go buy bread. And I go home and get yelled at, sleep in doghouse, etc., etc. Okay. So that's what they're talking about. In 57, they're saying, okay, here's your statement. If you studied hard, then you passed the course. What's the one thing that would make that a lie? You studied hard and did not pass the course. And is there one like that? Part D is clearly the negation. So whenever they ask you for a negation, ask yourself, what would it take to make it a lie? That's what you want. Now remember, don't go overboard. What's the negation here? Let me just talk to you about this one. Let's say I say to you that on Wednesday we will have review 2 for this chapter, and I will be in class on time. Okay, what would it take for me to be a liar on that? So in other words, if I come on time but I don't do review 2, I have lied. The other possibility is I go through review 2, but I come a half hour late. Either way, I lied, right? So, yeah, you got the idea. So what's the negation of an and? Either I didn't, what's the negation of P and Q? Not P or not Q. Now, does that sound familiar? Where have you seen this before? What's the negation? Where have you seen this before? What's the negation of this is what I just said a few minutes ago. Have you seen that before? Yes. What is it called? It's De Morgan. Yeah. And then what's its cousin? What's the negation of P or Q? And of course, you notice this thing had to be reversed in both cases, right? So if I say to you, I'll be in class on time, or I'll bring you ice cream, what would it take to make that a lie? I'm not here on time, and I don't bring you ice cream. How disgusting. Anyone else? Good questions. Well, where else do you want to go today? I mean, what were we were going to talk about Euler diagrams. I mean, that was another item that was checked. And I'll tell you this, every year that's a popular choice. People seem to have a little trouble with that. So I got to find it first of all. Where was it? Right after the conditional, wasn't it? Three, 5. So let's just, maybe I'll just pick a couple from there. So section 3.5. I don't know if we did. Here's another beer problem, number 18. All beer lovers like Schlitz. I think we probably did this one. All beer lovers like Schlitz. Isn't that the same as saying, if you're a beer lover, then you like Schlitz? It's the same. It's the equivalent. Part 2. All people who like Schlitz get drunk. So if you're a Schlitz lover, you are a person who gets drunk. Conclusion. All beer lovers get drunk. According to this argument, that is a valid statement. In other words, if you're in this circle, do you have to be in the GD circle? Yeah, sure do. So even though, we got these corny statements, the logic of that does follow. So that would be valid. Remember, when you do problems like this, make sure you write down valid or invalid. I've had people who I know did it right. They even put their marks in the right place, but they never told me their answer. Probably in too much of a hurry. Oh, let's see. How about something later on? Like, yeah, I'm not real thrilled about these, but we better get to them sooner or later. And that is these no problems, like 30, or all. 34. Okay, let's do 34. All pigs are fat. If-then form, if you're a pig, then you're fat. Okay, part 2. Nothing that is vegetarian is fat. You gotta get that into if-then form. Nothing that is vegetarian is fat. So if you're vegetarian, then you're not fat. So does that picture make sense? If you're vegetarian, then you're not fat. Okay, now the conclusion. Is there any conclusion we could have? They have 2 in the book. Pigs are not vegetarians. That seems to be valid, doesn't it? And how about the second one? Some pigs are vegetarian. Boy, it doesn't look right on here, does it? So it would have to be conclusion A. Yes, go ahead. 36? No professors are salseros. I don't even know what that... I still don't know what a salsero is. Does anybody? Tell me if you do. Okay. No professors are salseros. So here's the professors. I'm going to put the salseros over here. That seems to make sense. Okay. Second part of that one, some professors are rappers. Oh my goodness. Some professors are rappers. So that means, where do I draw? Yeah, that's pretty funny. Where do I draw the rapper circle? Partially crossing, at least partially crossing the P, correct? So, let me change colors here. So I'm going to say wrapper 1. Might have something like this, a wrapper 2. I mean, there's all kinds of possibilities, aren't there? By the way, is that a sum? Yeah, remember, in math, sum means at least one. So it could be even all of them. Okay, so think about all 3 of these. There's probably even more. Now, what are we supposed to do? Come up with a conclusion? Which one is true? Some rappers are not salseros. Is that true of all 3? Yeah. How about the second one? Some professors are not rappers. That would not be true in the case of R3, would it? You see that, how that would work for R1 and R2, but not for 3? So I definitely want A on that one, too. So let me just write that down. This was number 36. Okay, good. What do you want to do next? Actually, never mind. Should we start looking at let's look at the practice test and at least take a peek. Don't forget, for next time, I'm not going to give you a formal assignment, and when I collect your notebooks, I'm not going to look. You don't have to have the practice test in there, although it's good to see it and it helps you. I'm not going to take off if you don't have it. But remember, the whole idea here is if you don't use the practice test, you're missing a real opportunity to get yourself ready, because my tests will be pretty similar. So if you really make believe, and really take this baby and correct it, you really know how ready you are, and you'll know what your weak spots probably are. I don't think we didn't skip anything in chapter 3, so I don't have to ask you to skip any questions this time. Remember, all the answers are not only in the back, they're right behind the test. So, be strong and resist temptation, and don't play peekaboo. It's better. I mean, you can peek if you want, but it doesn't get you ready as well. Make believe you're really taking the test, and you can correct it, and then you'll find out the bad or the good news, and it really should be good for you. Okay, question pops up, number 18. Which of the following statements are tautologies? Well, do you remember what a tautology is? A logic statement that after evaluating it comes out T all the way down. Yep. And so how would you find out which of those were tautologies? There's no shortcut. You would have to basically do a truth table. I will say this, the shortcut might be this. If you're doing a truth table and you get one false, and all you're doing is looking for tautologies, wouldn't it make sense to quit? Yeah. I mean, if you're looking for a tautology, and you've got a false someplace, go on to the next one, because that one sure isn't it. Okay, so, alright. Let's see if you remember this one, about tautologies. I don't know, I'm trying to think of a way to phrase this. If an if-then statement comes out to a tautology, then what does that tell you? Besides, an if-then statement came out to a tautology. Yeah, that the first statement implies the second, an implication. Yep. Let's also, why don't we go through our rules real quick, huh? Okay, see if I can remember them in order. Rule? Mhm. Only, thank you. Only true when they're different. Just the opposite of, where they're only true when they're the same. Only false when the first is true and the second is false. What have I missed? I think we did them both. We did them all. Then there's the equal sign with the arrowheads on both ends, which means equivalent. What's the symbol for the implies that you were talking about a few seconds ago? So I do a if P then Q, and I find out it's a tautology. That tells me that P implies Q. And how could you write that with symbols? Yeah, an equal sign with the arrow pointing to the right. So P implies Q. Okay. I'm trying to, what have I missed? Okay, here, let's just review this and then we'll let you go for a day. How do you go about proving that an argument is valid? We did a few with Euler diagrams. How do you do it with a truth table? So, if I've got a couple, let's say, two premises and a conclusion, and we want to know if it's a valid argument, how can we go ahead and do this?
When the two premises are true along with the conclusion.
Okay?
In a line. And you see if there's any false ones with the true conclusion. Then it's false.
That's right. So, that's pretty good. So what you got to do is, you got to make up a truth table. And you need a column for which items? For each premise and for the conclusion. And then you look in the premise columns and you find out any lines where all the premises are true. Now, I use the word all because there might be like three, sometimes you can have 4 or 5 premises. The only ones you're interested in is the lines when all the premises are true. And in those lines, just like she just said, the only ones that are false are when you have a false conclusion. And if you even have one, it's invalid. But if all of the ones with true premises come out to true, then it's valid. That way is, with this, I'm never quite sure if I drew enough R circles. The cool thing about those truth tables is, boy, they just never lie. And so, if I really was up against it and had to really know, that would be the technique I would use.
Wait, if it has any true premises or all true premises?
All. All the premises aren't true, you're not even interested in those lines. Yeah. So but you have to do the whole truth table and then find all the lines where all the premises are true. And if there's even one false conclusion, that's got to be an invalid argument. Okay, so your informal, please, maybe you shouldn't emphasize that so much. What you really need to do is study for the test. And you got to do it this time because next time it's harder for you and I to get together. This way, if you do it, then we can I can go right at the things that have caused you grief and attempt to clear them up. I really want to do that. I want you guys to do it as well as possible. We only have one test score and one notebook, so this is a big step forward. We get another notebook grade. There's another opportunity for extra credit. And then there's of course, the test grade. 2 tests. Okay, Take care. Nice to see you back. Enjoy the weather.